Well, like the proportional odds assumption being very critical for proportional odds model. For the multinomial logic model, we also have a very important assumption, which has to hold for the model to work. That's called the IIA assumption, or if we spell out this acronym, it's called the independence of irrelevant alternative assumption. Okay? Sounds pretty complicated, and it is a complicated assumption. But to begin with, I can tell you there's no good handle right now to deal with, to test, or to address problems associated with violation of this assumption. There's no good tool, but we got to be aware of this. Recall that in the multinomial logic model, okay, some simple derivation can give us this result. That is the probability of y equal to a generic response category given x over the probability y equal to another generic response category is equal to, well, equal to the exponential of, well, given x got to be same, x and a bracket, the difference of two regression coefficients vector. Remember that in multinomial logic regression model, we almost always choose, shall I say, always choose a reference category. So let's say the reference category is J, okay, J. So the comparison for this regression coefficient vector is M compared with J, the reference category. And for the other vector regression coefficient vector is N over J, right? We run the regression, we pick J as a reference category, right? So the regression coefficient vectors here about odds comparison of M over J and N over J. But here, what if people are interested in the odds comparisons of M Mary over y equal to M, that is Nancy? Well, what we can do is to apply this function, right? We take natural exponential of the same x, we got to give x, then bracket, take a difference of these two regression coefficient vectors, okay, for their respective odds comparison against the reference category J, right? So what does this mean? Here we have to be aware that the odds in this case do not depend on other outcomes that might be available. Okay, so in this case, it does not involve any other regression coefficient vector. Okay, it only involves beta m over j and beta n over j. Okay, so this is known as the independence of irrelevant alternative property, or simply IIA assumption. And this is a pretty convoluted assumption. And to understand the substantive meaning of this, let me give you an example. Let's say a person has two choices of transportation. So either he's going to choose, or that person going to choose car with a probability of 0.5, that is 1.5, and a red bus with a probability of 0.5. So for that individual, right? So the odds of taking the car versus red bus are, well, for odds comparison, basically take a ratio of this to probability. It's 1, right? It's 1. Okay. So what it means to have this IIA assumption holds? Well, let's say a new bus company is started or is introduced into the game. It is identical to the current service except that the buses are blue. So that individual used to have two options. One is car, another one is red bus. Now we have another option that is blue bus. For the IIA assumption to hold, it requires that the probability for that individual to choose car is 1/3. The probability of choosing red bus is 1/3. And the probability of choosing blue bus is 1/3. Why? Because so that odds of choosing car versus choosing red bus is still 1. That is 1/3 over 1/3. Okay? This means by introducing new alternatives, okay, the original relationship among the old choices don't change in this case. Okay? Okay? And what does that mean? That means all the choices, okay, regardless whether they were available or they are newly introduced, they have to be distinct enough. Well, in this case, that might not be true because there's a reason why one chooses car versus bus, right? So the thought process could be, well, either bus or car. Once one picks bus, okay, then that individual gonna pick between, well, gonna choose between blue bus or red bus. So the introduction of blue bus does change the original relationship, to be fair. So a more natural thought process would be, so car is half, right? Red bus or blue bus is half. Then between the two, red bus is half of half. So that's a quarter. And this is a quarter. Then what is the odds of car versus red bus? Well, it's half over a quarter. It becomes 2. Right? It was 1. So more likely, this introduction of a new choice change the original odds relationship. Okay, so this is a very simple example to expand the IIA assumption, and in practice, well, it can be more complicated. But the simple idea is that for the IIA assumption to hold, we're better to have distinct choices, that are different enough, and they can be differentiated by covariates. Okay, and also note that until today, as I'm talking about the IIA assumption, there is no good statistical test designed to check if the IIA assumption holds or not. And there is some solution to the violation of the IIA assumption, but it's kind of complicated and requires a lot more computational power.